Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration by parts. This is part 20, and I encourage you to check out all the videos prior to this one in the integration series. Subscribe so that you don't miss out on any of our future uploads. Getting into today's business. Recall the product rule in differentiation. If we have a product of functions uv, then we would say the derivative duv dx being equal to du dx times v plus u times dv dx. Now, reversing the process, we would have the integral of d dx of uv dx is equal to the integration of du dx v dx plus the integration of u dv dx dx. Now, what we would have after integrating is uv is equals to the integration of u prime v dx plus the integration of u v prime dx. Rearranging the last term, we get the integration of u v prime dx is equal to uv minus the integral of u prime v dx. Let's label this as equation star. That will be a crucial formula. Now, equation star is also known as the integration by parts formula. Note, there is no need to know how to derive it. Let's just master it for now the way it is. Now, let's take a look at the tips on the integration by parts. Tip number 1, identify the u and the v prime from the integral. The u need to be a function easy to differentiate and reduce in degree or power when differentiated. 2. From v prime and u, find the v and the u prime respectively. 3. Substitute for the u, v, u prime, and v prime into formula star and the final integral. Now let's take a look at example 1. Find the integral of x minus 1 times e to the 3x dx. The solution. Consider the integral terms. These are x minus 1 and e to the 3x. For x minus 1, it is easy to differentiate and reduces when differentiated. On the other hand, e to the 3x is easy to both integrate and differentiate. However, it doesn't reduce its degree. Therefore, let's let u be x minus 1 because it's easy to differentiate and it reduces its degree when differentiated. Remember tip 1. And we let the v prime be e to the 3x. Now we need to differentiate u so that we have u prime. That will be du dx, which is 1. And integrating e to the 3x, we get 1 over 3 times e to the 3x. Now that we have obtained our u prime and the v from formula star, recall, we are going to substitute for uv, u prime, and v since we already have u and v prime from the original question. Substituting for the uv, u prime, and v prime, we are going to get the integral becoming x minus 1 times e to the 3x minus the integral of 1 times 1 over 3 e to the 3x dx. We have substituted for the u, x minus 1, for the v, e to the 3x, minus the u prime, which was 1, and the v, which is 1 over 3, e to the 3x. Now, simplifying further and integrating the last term. It's way easier to integrate now because we only have one part with the x term. So in integrating that, we are going to get x minus 1 times e to the 3x minus 1 over 3 e to the 3x plus c, the constant of integration. Of course, we can simplify further by factorization, factoring out e to the 3x, but for the sake of this example, I won't go that far. Now, let's look at example 2. Find the exact value of the integral from 0 to pi over 2 of x cos x dx. The solution. Consider the integral terms. So we have x and cosine of x. X is easy to differentiate and reduces when differentiated. It reduces in terms of the degree or the power. On the other hand, cosine of x is easy to both integrate and differentiate, but doesn't reduce its degree. With that in mind, it means then that we are going to let u be equal to x and v prime be cos x. We find the derivative of u so that we get that u prime is 1 and integrate v prime to get v so that we get sin x. The next thing, of course, from formula 1 is to substitute. So now we have our uv, u prime, and v prime. Substituting, we are going to get our u, which is x, times our v, which is sin x. We evaluate this because this is already integrated from 0 to pi over 2, minus the integral from 0 to pi over 2 of u prime, which is 1, times v, which is sin x dx. Now, we integrate the part that is on the far right. With that, we are going to get cos x. Now, we've got two parts, and the limits are the same. So if the limits are the same, we can combine the two parts so that we have x sin x plus cosine x from 0 to pi over 2. And then we evaluate by substituting the upper limit and subtracting with what we get from substituting with the lower limit. So in this case, we are going to do that, and we get to that stage of pi over 2 plus 0 minus 0 plus 1. This is where we get the values that are evaluated from pi over 2 and 0. So we get those values there. Therefore, our answer becomes pi over 2 minus 1. Let's take a look at the last example for this session. Find the exact value of the integral of 4x squared times e to the 3x dx. Solution. Consider the integral terms. So we've got two integral terms, 4x squared. Of course, we can take the 4 outside because it's a constant, but I decided to keep this inside our integral function. This 4x squared is easy to differentiate and reduces its degree when differentiated. Whereas the e to the 3x, inasmuch as it is both easy to integrate and differentiate, it doesn't reduce its degree. Therefore, let u be equal to 4x squared and the v prime be e to the 3x, implying that our u prime becomes 8x and our v becomes 1 over 3 times e to the 3x. Now with that, from formula star, we can substitute for the uv, u prime, and v prime. In doing so, we are going to get 4x squared times 1 over 3 e to the 3x, because the 4x squared is the u, and the 1 over 3 e to the 3x is the v, minus the integral of u prime, which is 8, times v, which is 1 over 3 e to the 3x dx. Simplifying further, we are going to get 4 over 3 x squared e to the 3x minus 8 over 3 times the integral of x times e to the 3x dx. Let's label this one equation 1. Take note, the integral still consists of a product of variables x and e to the 3x, implying that we are going to make use of the integration by parts once again for the second time. Right, so on the left, we have the question and the key point, which we obtained in the previous page, equation 1. Now we consider the integral x times e to the 3x dx. Therefore, we let our u be x and our v prime be e to the 3x. And I'm sure we understand why we made that selection. This is because the u is easy to differentiate and reduces in its degree, implying that the u prime becomes 1 and the v becomes 1 over 3 e to the 3x. Now, the integral of x times e to the 3x dx is going to be x times 1 over 3 e to the 3x, because the x comes from the u, and the 1 over 3 times e to the 3x is the v, minus the u prime, the integral rather of the u prime, which is 1, times v, which is 1 over 3 e to the 3x dx. This time around, the integral that is on the far right is way easier to integrate. So upon integrating, we are going to get x over 3 e to the 3x minus 1 over 9 times e to the 3x plus c. Let's label this equation 2. Now, substituting equation 2 into equation 1, remember our equation 1 is on the far left. We are going to replace the integral integral of x times e to the 3x dx with what we obtained in equation 2, so that we have that bit over here in square bracket or parenthesis. And take note, the c in 2 is dropped so that we have a unique c in 1. It wouldn't make sense to have two constants of integration when we are integrating just one problem, in as much as we partitioned our problem into two parts. So we drop the c from the second equation so that we have the ultimate c for equation 1. Now our final answer comes out as 4 over 3 x squared times e to the 3x minus 8 over 9 times x times e to the 3x plus 8 over 27 times e to the 3x plus c. If you have made it thus far, thank you so much for watching Numbers Simplified. I'll leave you with the following task. Integrate from 0 to 2 x divided by e to the x dx. And let me know in the comment section how you solved this problem. And let me know as well of any other problems that you might have encountered. Thank you so much for watching Numbers Simplified once again. God